Hey everyone, welcome back. So today we are going to solve different problem from our series of problems. So the problem is a rotate image. It is also a medium from the Leetcode, and this time we are going to use matrix. So till now we were using linear array or vector to solve the problem, but this time we are going to use matrix, or you can say 2D array. Okay, so our question is rotate image. So in this question you have given array like this, okay, and you have to rotate it, means the 1 and 2 will come here and 3 4 will come here. You can say you are rotating your image to right side, just like you rotate your image in the gallery or while editing your image. So you just have to rotate 90 degree to the right. So let's take another example. So we have 1 2 3 4 5 6 7 8 9. Now you have to rotate it by 90 degree. So while rotating, what will happen? This 1 2 3 will come here at the end as a column, then after that 4 5 6, then after that 7 8 9. Okay, so this is our output. Similarly, for this example, we just have to rotate by 90 degree. First we will write this row as a column here. So 5 1 9 11, then second row 2 4 8 10, then third row 13 3 6 7, then 15 14 12 and 16. So this is our output. So this problem is basically a easy problem until you are brute forcing it, means you just have to pick a single row and arrange it into a column, right? So let's see how we can arrange it into the column. So for this we have to make a formula, you can say. So for this we have to make formula. So this is our index number, right? Similarly here, now when you were at the index number 0, means I equals to 0 and j equals to 0, right? Means you were at this position. Now you have to pick this element and place at this position. So what is this position? This position is I0 J3, right? When you were at this position, you have to pick this value and place at this position, and this position we have I0 J3. So we were able to place our 5 here. Now at I0 we have J1, so we are talking about this value. Now we have to place this value at this position. So at this position we have I1 and J is 3, right? So I1 J3, so our J will remain same. So let's move to the next element. For this element we have to place it here. So our I is still 0 and J is 2. Here I is 2 and J is still a 3. Similarly for the 11, we have I0 J3 and here I is 3 and J is 3. So J is 3 here and I is 3 here, and the J will remain same here. Okay, so this number of iterations we have to make to place these values in this column, right? Similarly, if we take row number 2, our I will become 1 and J will become 0, then 1, then 2, then 3. Similarly, here our row will become 0, 1, 2 and 3, right? Because it will still be moving in this direction. But now for this case, our J will become 2 because it will decrease by 1 here, right? We are at this column. Now if you look at this pattern, what can you see? That this I is iterating over our original matrix and this J is iterating over column. Similarly, you can see this I is iterating over the column in this second matrix, or we can say answer matrix, right? So at J equals to 0, I is 0, J1 I1, J2 I2, J3 I3. So can we use same J to iterate, right? But this J will be used here as a row number, right? So we were able to figure out. So if we write it into a formula, let's say this is our answer matrix, right? It should be something like this. So we have to assign value from matrix to the answer. So we are iterating over the matrix, so our I will be this one, right? And for the J it will be similar because we are simply iterating over the J. Now this J we are using for this matrix as a I, and I is our row, so our J will come here, right? Now we just have to look for the column. So how it is moving into the column means how it is jumping left to right, and this left to right jumping is depending on the I itself. So can we write something like this? N is my size of matrix, means the number of element in this row is 1 2 3 4. So 4 minus, if I'm at the I1, I'm talking about this I, if I'm at the I1 minus 1, then my column number will be 2, which is equivalent this j equals to 2. So my final formula will become n minus I minus 1. So as my I is increasing here my j is decreasing here, right? Let's say my I was 3, then my j will become n minus I minus 1. So 4 minus 1 minus 1, it will be, sorry, I was 0, so 4, it will become 3. I was 1, j will become 4 minus 1 minus 1, 2. Then I equals to 2, j will become 4 minus 2 minus 1, 1. I is 3, so j will become 4 minus 3 minus 1, 0, right? So here my I is increasing and my j is decreasing. So you can remember this formula because this concept used in most of the problem. The code is very simple. You just have to now run to loop and write this formula. This is your whole code. Okay, so let's write this code. So here you can see this is our example 1 2 3 and here 1 2 3. So let's first declare int n equals to matrix dot size. So here they have given a matrix of n cross n, so the number of rows and the number of columns will be same, and we will declare a vector of vector, means 2D vector. So my vector will be size of n cross n. So this is a declaration of 2D vector, and the size of the row is n and the size of the column is n, and the cells means initially these cells containing 0. Now after this we will run a loop. Now we have written a nested loop. So nested loop is help us to iterate over the 2D matrix. So the first loop iterate over the rows and the second loop is iterate over the columns. Then answer j n minus I minus 1 equals to matrix of I and j, then here matrix equals to answer. So in this problem the return type of the function is void, so that means we cannot return our answer, so we have to assign it to the matrix itself. So let's submit it. So here you can see our code got accepted. So the brute force is very simple. You just have to implement nested loop and the formula. Now the real questions comes. You have to rotate the image in place. In place means we have to make changes into the original array itself. We cannot make a duplicate or extra matrix. So which means you have to modify the input 2D matrix. Do not allocate another 2D matrix and do the rotation. In this solution I have created another 2D matrix, but the question asked not to do it. So the problem is asking us to rotate our without using extra space, right? So this is our example and this is our a rotated array, right? So we have to reach here. So if you look at it, if you rotate your array, the middle element will be same, right? Because it is in the center, so our image is rotating about this center, and the 7 will be at this position, right? And the 3 will be at this position. So first somehow we will be able to bring our 7 at the top and the 3 at the bottom. So for this we can reverse our matrix. So after reversing our matrix, it will become 7 8 9 4 5 6 and 1 2 3, right? This middle will be in the middle and the last row will shift to the first row and the first row will shift to the last row. Now we able to reverse our matrix. Now if you look at it, 7 5 3, so we were able to get our diagonal seam. Now we just have to handle these elements, right? So if you look at it, here we have 8 4, here we have 4 8. Somehow we able to swap them up. Similarly 1 9 9 1 2 6 6 2. So if I swap these values, then it will become 7 4 1 8 5 2 9 6 3. So if you look at it, we were able to get our answer. So the process is reverse the matrix, then swap the values across the diagonal, because we were able to rotate our diagonal, you can say, and we just have to observe in the answer and the matrix. So here we had 4 8, here we had 8 4, so you just have to swipe them up. Here we had 9 1, here we had 1 and 9, just swipe. Similarly 6 to 6, just swipe. So we were able to get our answer. So for this we just have to first reverse our matrix, right? Then again we will run our loops, then swipe them up. Now you have to skip this diagonal, right? Because it already swiped. So 0 1 2 0 1 2. So whenever I and j is equal, that means it is our diagonal, right? Because at 0 0 it is 7, at 1 1 it is 5, at 2 2 it is 3. So whenever my I is equals to j, that means it is diagonal. So we can skip that diagonal. So we will write I not equals to j. That means we are only swiping when it is not a diagonal. Then we will use swipe function matrix of I j. So when we were I0 j0, we skipped 7, then we are at here. So here my I is 1, j is 0, right? So I will be swiping with the j and I, right? Because at this position I have I1 j0, and at this position I have I0 j1. So if you look at it, we just have to make this row here column, right? And this column here make as a row. So we will be able to swipe them up. Similarly for this, I is 2, j is 0, and here I is 0 and j is 2. So this I can be used for this 2 and this j can be used for this I, right? So we are using them as in a cross. So this is our whole code. So let's write a code. Okay, before moving, what is the time and space complexity of this solution is that we used extra space. So it took around wig of n square, right? Because our matrix size is n cross n, so it will be n square, and the time complexity will be n square, right? Because it is a matrix. So if we want to iterate over a matrix, we have to run two loops and it will be nested. So that's why it will take n square of time complexity and n square of space complexity. So now let's modify this code with our optimized code. So it will be reverse of matrix begin matrix dot end. After that, here we will write I not equals to j, swap matrix of I j comma matrix of j I. This time we don't have to assign matrix equals to answer because we directly modified our, okay, we made a little mistake in our code. Here our j will not be iterating till the n, it will be iterating till the I, because we are just crossing the I and j, means this I is used here as a column and this j is used as a row. So we don't have to go till n for the j also, so we will go till the I. So here you can see our code got accepted. So this is one of the most easiest problem you can find on the Leetcode, which is also a medium. Okay, so dry run different example on this concept. It is really easy. Okay, you will be able to understand. So that's it for today. Until then, thank you everyone. Have a nice day.